Hi everyone, my name is Dr. Sri Krishnan, Assistant Professor EC Department. I am handling sensors and robotics subject for the third year EC. So today's chapter will be Introduction to Robotics, the history, followed by the robot anatomy and some other applications. So if you see, I will not go deep into the history as such, just for the sake of knowledge and purpose. It all started from the very beginning, the mechanical bird. The Greek mathematician Archytas built the first mechanical device. So from the ancient time itself, the robotics has found its prominence. Followed by other, of course, we know the very famous eccentric scientist by name Leonardo da Vinci. He also sketched some plans during the Renaissance period and influenced the future robotics. So these are all what the history is all about, the planting the seeds of robotics. And of course, there are Tesla, the robot controlled boa. Boa means what? It's a kind of a serpent. And it is an autonomous controlled ground-making advantage, that achievement that happened during that time in 1898. And the word robot was introduced by this gentleman by name Carl Sapek. So that's what the word robotics have come into the picture. And as the time went on, with the advent of first industrial revolution, second industrial revolution, third industrial revolution, now to the fourth industrial revolution, the robotics have evolved. But there are some fundamental laws which governs the working of the robots. So we will see what are those fundamental laws which was proposed by Isaac Asimov, the scientist. So there is a law here. How it goes, I don't know.
Possible.
Possible. So how the robotics have evolved over the course of time and integration of robots in our daily life with the advent of AI. So definitely robotics will definitely found its niche here. Various industries have taken robotics, and especially in the car manufacturing sector, robotics have been employed in development of engines, assembling them, and developing a complete vehicle. So robotics definitely has its use now. Now let us see what does this definition of robots mean. Okay, we should know the real definition. So the Robotics Industries Association defines robot as follows. A robot is a reprogrammable, multifunctional manipulator. The word manipulator itself, I will tell you when we go into the subsequent classes about robotics. It's a manipulator designed to move materials. The word itself is now very self-explanatory. Parts, tools, specialized devices through various programmed motions for performance of variety of tasks. So suppose you want to move some items from one position to another position, or from one place to another place, robots can be used. Especially when you are going to, in the case of building and logistics now, pick and place things where human effort is there, robotics have been able to achieve that task with less intervention. So many companies such as Amazon, Google, to name a few, have employed robotics for their building and logistics applications. So robotics definition has been coined, again I am telling you, it's a reprogrammable, multifunctional manipulator designed to move materials, parts, tools or specialized devices through various programmed motions for performance of varieties of tasks. It's a very simple definition actually speaking, although it deals with the tasks, material movement, parts, tools and devices. So actually these movements will not occur as it is. They have to be programmed. So they have to be programmed so that you can achieve the required output. So the the robots are programmed for these particular kind of task. So in simple terms, if I say a robot is an autonomous machine capable of sensing its environment, carrying out computations. It will make some calculations and it will make decisions and perform actions in the real world. So in a simple way, that is what a robot is. It's a completely an autonomous machine. It will check for the environment and react accordingly. So what is the robotics then? It's a discipline dealing with design, construction and operation of robots. As such, the simplest definition of robotics is it's an engineering discipline, robotics. Robots is a machine. The entire discipline we call it as robotics, which deals with design, construction and operation of robots. But we cannot use the robots as it is. There are some well-defined laws that will govern the working of the robots. The scientist by name Isaac Asimov has proposed and formulated 3 laws of robotics. I will read them. I will explain to you one by one. So what is this Isaac Asimov? Isaac Asimov was an author who specialized in science fiction, and certain laws were formulated by him to govern the working of the robots. Let us go one by one. The first law: a robot may not injure a human being through inaction or allow a human being to come to harm. The word itself is very self-explanatory. The robot should not injure a human being because they are supposed to help, assist human beings. At either way, they should not perform any harm to the human being. And it should not allow a human being to come to harm. So the first law is about injuring a human being, and robot should not injure any human being. Second law: the robot must obey the orders given by its human beings, except where such orders should conflict with the first law. Again I am telling you, what does this mean? Whatever the human gives instruction to the robot, it must follow, as long as it does not conflict with the first law. So robot should always obey the humans. Whatever the commands or the instructions which are given by the human are to be followed by the robots. Moving on to third law. The robot must protect its own existence. That is, it should be able to protect itself from any other conflicts, as long as it does not collide with the first and second law. So it's a kind of a law. It's a well-defined law formulated by Isaac Asimov to govern the working and the behavior of the robots. So why these laws were framed? These laws were framed to prevent robots from harming humans, especially when they serve humanity and self-preservation. So what happens is, why these laws were, the real reason for creating such laws were, as he being the science fiction writer, many stories were there where the machines control the humans. So that kind of a scenario should not happen. So the humans should be under the charge of machines or robots. So keeping that into account, these laws were framed. Moving on. Anatomy of robots. Anatomy means internal parts of the robots. The anatomy of robots refers to various components and systems that work together to enable the robot to perform its tasks. So, the basic anatomy of a robot will be same, but there will be some small differences. Again, that will be depending upon the applications of that robot. So, if a robot is going to be an industrial robot, it's going to be a domestic robot, it's going to be a humanoid robot, whatever kind of a robot it is, the basic anatomy will remain the same or similar. So, what are the common basic elements that a robot will share? The common units are power conversion unit, sensors, actuators, controllers, user interface, manipulator linkage, base. So these are all some common basic elements that are present inside the anatomy of a robot. Let us go one by one. Body frame or frame. The frame is or the body is going to be serving as the robot's structural skeleton. So the frame or the body of the robot is going to support the skeleton, supports the robot's skeleton. What it does is it provides support and houses all other components. That's what the body does. Next, for that, the materials used for the body are metals, plastics, composites. Again, it will depend upon the kind of robots is going to be used. So, if the body is going to be lightweight or industrial robots, accordingly the body material also will change. Next, actuators. Actuators are nothing but the muscles of the robot. These are the devices that enable movement by converting the energy. So what actuator does is it converts your electrical or hydraulic energy into a mechanical motion. So there are different types of actuators in the robot. One is your electric motors, hydraulic actuators, and pneumatic actuators. So our electric motors is meant for precise and controlled movements. Hydraulic actuators for high force applications, especially which is used in industries. Pneumatic actuators for faster, lighter movements using compressed air. Then, sensors. Sensors are the nervous system of the robot, providing it with the ability to perceive and interprets its surroundings. There are different types of sensors which are present in robots. One is your vision sensor, proximity sensor, force sensor, temperature sensor, and touch sensors. Vision sensors, LiDAR, for detecting objects, navigation, or human interaction. Proximity sensors, infrared, ultrasonic, for detecting distance from the objects. Force sensors to measure the force or the pressure applied. Temperature sensors for detecting environmental or industrial conditions. And touch sensors for interaction, especially with regard to humanoid robots. Then, the main important part of the robot is your controller or the processor, which we call it as the brain of the robot. The controller or the processor is the brain of the robot. It processes input from the sensors and controls the actuators based on the programmed instructions or artificial intelligence. The controller runs the software, drives the robot functions, and improves its decision making. In some robots, which will also the controller will also involve itself in machine learning, deep learning, or AI related decision making actions. What will happen is it will improve the performance over the time. So very much, as I told you, AI and robotics have become very much interlinked. Power supply. Again, the robots require a continuous sources of power supply, which would require from batteries, fuel cells or power cables. Batteries, if you say, for example, lithium-ion batteries for mobile robots or drones, fuel cells for long operational periods, and power cables for stationary robots, especially which are going to be permanently housed in industrial houses. Then, end effectors. End effectors are nothing but the hands of the robot, designed for specific tasks. It's nothing like, it can be, you can imagine the end effectors as kind of an arm. For example, you imagine a robot which is going to pick and place it. So I can just see, this is my arm. I am going to pick an object and I am going to take it and I am going to place it in somewhere. Exactly, the robot will simulate the arm of a human. This you call it as an end effector. So it becomes a tool or a hand for a robot. But not just hands, different robots will have different applications. So it can have a welding torch, it can grip, it can have suction cups, it can have drills. So hand is just an example, but there are not all robots will have a hand. Some will have suction cups, drills, depending upon the robots which is going to be employed. Next, software and AI algorithms. Very important part of the robot is your software controlling, because the software is meant for controlling and coordinating robots' action. AI and machine learning will help robots to perform complex operations, adapting to the environment and enabling it to perform decisions in real-time scenarios. In human robots, NLP, natural language processing, enables them to understand and respond to the human speech. Next, communication systems. Many robots are employed with communication systems, especially for Wi-Fi, Bluetooth, 5G, Zigbee. You take as many protocols you want. That will help them to connect with other devices or networks for remote control, data exchange or updates. Some high-end robots can interact with humans using voice commands or gesture recognitions. Mobility systems. Robots designed for movement, require certain specialized components that will help them navigate through the environment. You can have a wheeled or tracked systems, you can have a guided vehicle, you can have legs, or you can have flying mechanisms. Guided vehicles is meant for mobile service robots, legged systems for humanoid robots which will walk on just like a human, that may even able to cover rough terrains, legs with actuators to mimic walking, talking, running, you name it. Flying mechanisms, drones, very good example of drones. And finally, the feedback or control mechanism. You can see the feedback system here. The robots use feedback mechanism to adjust their behavior in a real-time scenario. These feedback systems ensure that the robots can maintain balance, positions and execute precise movements. You can see here there is an input here which is given to the summing part, and from there it goes to the controller. From the controller it goes to the process, and from the process you will get the output which is desired. From the output, a part of it will be given as a feedback through sensing elements and will again given back to the summer. So this kind of continuous feedback will help the robot to perceive the environment better and respond according to the environment and perform its tasks. So this is what the entire anatomy of the robot is all about. So the next session we will be talking about the different coordinate system of the robots. Thank you. Thank you very much.